Alright, I'm going to talk about sampling distributions of the mean. We're specifically going to work with an oil change question. So let's get started. So first it says, the shape of the distribution of the time required to get an oil change at a 15-minute oil change facility is unknown. However, records indicate that the mean time is 16.8 minutes and the standard deviation is 4.8 minutes. So these are the records. So we're going to conclude that the mean of oil changes is 16.8 minutes and the population standard deviation is 4.8 minutes. So we have that information. Now, knowing the population standard deviation is going to be important. That means we can do a Normcdf instead of tCDF. But we need to make sure it satisfies the Central Limit Theorem in order to conclude that it's a normal distribution. So let's say we have a random variable x which equals to the time it takes for an oil change. Big question, is x normally distributed? Well, does it say it? It says the shape of the distribution required to get an oil change at a 15-minute oil change facility is unknown. It's unknown. So is it normally distributed? We're going to say no. The time it takes to get an oil change is not normally distributed. But the good news is that we can transform something that is not normally distributed. For instance, household incomes here. We see that they are right skewed, not normally distributed. But if we take samples of size n equals 4 and create a sampling distribution, which is the distribution of the sample means, what it does is it transforms it from being right skewed to normally distributed. Now this isn't quite normally distributed because this sample size is too small. So it's still a little bit of a tail on the right. But if we increase this sample size, we can get this to be more normal. But how normal? Let's see. To compute probabilities regarding the sample mean using the normal model, what size sample would be required? A good guideline for that is that n has to be greater than or equal to 30. But remember, this is only the case when x is not normal. Remember, in our question, nowhere did it say that the distribution of the oil changes were normal. So since oil changes are not normal, we need this extra condition that the sample size needs to be at least 30. And notice that in the question that we're going to do, it says that we have 35 oil changes. So let's read the question. What is the probability the random sample of 35 oil changes results in a sample mean time less than 15 minutes? A sample mean, let me underline that. We're talking about a sample mean less than 15 minutes. So what we're trying to find here is the probability that x bar is less than 15. Interesting. Notice that it's a sample mean, right? Well, that's what we need the sampling distribution for. Since n is greater than 30, the sampling distribution, we say x bar is approximately normal with mean 16.8 and standard deviation, well, now we call it the standard error. It's going to be 4.8 divided by square root of 35. Very important. This is very, very important right here. Please remember this. That's called the standard error. We divide by square root of 35. So every distribution of the sample means is different depending on the sample size. In fact, as the sample size gets bigger, the dispersion decreases. This is the dispersion. It's the standard error. Used to be called the standard deviation. It gets smaller as n increases. So now n is 35, so we have a specific sampling distribution. So since we know sigma, we're going to do Normcdf. We have a normal distribution, not a t-distribution, which you'll learn about later. I want to point out that we're trying to find less than 15 minutes. The probability that the mean is less than 15 minutes. Let's get a picture of that. We have a normal distribution, a normal curve. In the middle, we have 16.8. We're going less than 15, so we're shading to the left because less than goes to the left. So this is going to be equal to Normcdf, the lower bound, which is negative 9999, the upper bound, which is 15, the mean, which is 16.8, and the standard error, which is 4.8 over square root of 35. So let's plug that into a calculator. So second distribution, Normcdf, negative 9999 comma 15, comma 16.8, comma 4.8 divided by square root of 35. And there we have it. This equals to 0.0133. So that's Normcdf. We plug in the lower bound, the upper bound, the mean, and the standard deviation, or in our case, the mean and the standard error. So we found the probability. For probabilities, we use Normcdf. Next question. On a typical Saturday, the oil change facility will perform 35 oil changes between 10 a.m. and 12 p.m. Treating this as a random sample, at what mean oil change time would there be a 10% chance of being at or below? Okay, let's move this up. I want to point out that 10% chance of being at or below is called the 10th percentile. And I want to draw a picture for you to give you a good visual. The 10th percentile is going to be the oil change time. Let's call it some x bar, such that the area to the left of that is 0.1, which is 10%. So it's some sample mean that is a low sample mean, where 10% of the times are going to be shorter and 90% longer. And we're talking about the mean of 35 oil changes, right? At what mean oil change time would there be a 10% chance of being at or below? So at or below is over here, and this is a mean. So when we're trying to find a value down here, we use inverse norm, and we need to plug in the area, the mean, and the standard deviation. In older calculators, this used to say area to the left, and there was no tail. That's only a new calculator thing. We used to always have to plug in the area to the left, the mean, and the standard deviation. So we're gonna plug in inverse norm, 0.1, the mean, which is 16.8, and the standard error, which was 4.8 divided by square root of 35, and that's it. That's all you do to find the answer to this question, which wants to know this mean oil change for 35 oil changes time. We can say that x bar equals this, which equals to, let's see, second distribution, inverse norm. We're going to plug in 0.1, comma, 16.8, comma, 4.8 divided by square root of 35. So we get 15.76, and that's in minutes. All right, so that answers the question. Hope that helps.